All right, this is part 2 of your Unit 3 milestone review. So during the first video, we covered the first page, which had to do with Pythagorean theorem. So now we're going to look at the second page, which is all about volume. Now, what's important for you to know is that you're not expected to memorize the formulas. So what you're going to want to do is be able to use the formulas. So we're just going to run through each one. As you can see, I have the formulas already written on your chart. And we're just going to go through and use the calculator to get to get our solution. So first up is a sphere. So sphere is a ball. So basically what we're talking about is maybe you're trying to figure out the volume of a balloon. Or maybe the volume of an orange. So what we're doing is we're looking at a ball. Well, if you think about a ball is 3 dimensions. So there's 3 measurements that we can take on a ball. And I'm not very good at drawing, so just bear with me here. But let's pretend that this is our ball. But it's 3-dimensional. So what I'm going to do is mark the center. So that's the absolute center of our orange. Okay. So I know that it's 3-dimensional. So I'm going to make it look like, it's 3-dimensional here if I can. All right. So there are 3 measurements in a ball. There is the measurement from the center going up. There's the measure from the center going to the side. And then there is the measurement of the center coming out towards us. Well, if you think about what that measurement is, for every single one of those, that's the measurement of the radius. So our formula is 4 pi radius cubed, because I have 3 radii in there, and then divided by 3. All right, so let's say, given this picture, let's say that I know the radius is 2 inches. All right, so if I want to find the volume of my orange here, and the radius is 2 inches, then what I need to do is 4 times pi times 2 to the third, and then I need to divide my answer by 3. All right, now what you need to do is pay attention to what the question says. If it says to use the pi button, or you might be told to just use 3.14. So just make sure you read the directions on the test. So here's my calculator. I'm going to do 4 times, I'm going to use 3.14 for pi, times. Now, let's say you know how to do an exponent. Let's say you don't know how to do an exponent. You can still work this out. If you know how to do an exponent, then you could say, there is an exponent button over here. You would say 2, press the exponent button, to the third. Or let's say that you didn't know that. Another way to get 2 to the third is to just do 2 times 2 times 2. And then once we get our answer, we need to divide it by 3. So the volume of our orange is 33.5 inches cubed. And the reason why our inches are cubed is because this 2 right here was actually 2 inches times 2 inches times 2 inches. So we also have inches to the third. All right, nice job. Next up, cylinder. So the deal with a cylinder, if you think of a stack of coins, so at the bottom or at the top, however you want to think it, you have a coin. And then you're going to make a stack of these coins. So basically, one coin is a circle, which is pi r squared. But then we have them stacked up. So we have to take pi r squared, which is a circle, and then multiply it by how tall our stack of coins is. All right, so on this problem, let's say that I tell you this measurement, that measurement right there is 8 millimeters. And I tell you that this measurement right here is 6 millimeters. So to go to our formula to find the volume, we need to do pi times the radius. Now, the measurement I gave you is not the radius, and I know that because it's drawn all the way across. So the radius is just going to be half of that. So that means I need to do 4 squared, and then multiply it by the height, which is 6. All right, so then we grab our calculator. And again, if you don't know how to do exponents or you don't feel comfortable, you can just multiply the numbers. So 3.14 times 4 times 4 times 6. And that gives us 301.44. So the volume of this is 301.44 millimeters cubed. Now, watch for what you're asked to round to. So that one only had 2 decimals, so they might have you just go ahead and put that. All right, next up is a cone. So a cone, if you think about if you play a sport, cones are used often. Sometimes in construction, you might see a construction cone as well. And of course, there's always good old ice cream cone. But let's say we want to find the volume of this cone. So we need to know the radius and the height. So I'm going to tell you that the height of the cone wouldn't be the measurement of the side. It's going to be the measurement straight down the center of the cone. So let's say that that is, I don't know, how about, 3 feet tall. So let's say there's a big construction cone. Okay. Let's say that the radius of this is 0.5 of a foot. All right, so we need to find the volume. So here we go. The volume is pi times the radius, which is 0.5 squared. So I'm going to put that in parentheses so I don't lose track of my decimal, times the height of the cone, which is 3. And then a cone is divided by 3 as well. And that's because 3 cones can fit in a cylinder. All right, so I'm going to grab my calculator, clear my last one off. All right, so here we go. So 3.14 times 0.5 times 0.5 times 3, and then divide our answer by 3, and we get 0.785. So the volume of this cone is 0.785 feet cubed. And again, you just need to see what you're asked to round it to. If we're asked to round to the nearest tenth, then I don't need to worry about the 5. That 8 is going to tell me to round the 7 up. So that could be 0.8 feet cubed. All right, so last one. When we learned this, we looked at water and took cylinders and cones. And I had you make a guess as to how many cones you thought would fit inside of a cylinder. So I'm going to try and sketch this out. So, no laughing, of course. So let's say we have this cylinder. Okay. So the question is, how many cones, so let's say we dropped a cone in here, how many cones that have the same height and the same size opening, how many cones would fit inside of a cylinder? Some of you guessed 2, some of you guessed 4, but the correct answer is 3. We could fit 3 cones into this cylinder. So, because that cone's right there, but we have space for another cone out over here, and then we have space for another cone out over here. So remember, we're dealing with a 3-dimensional object. So even though this pink one is right here in the center, it's not touching any of the sides. So we have enough space for a cone over around here and enough space for another cone over around there. So 3 cones would equal 1 cylinder, which means that 1 cone is a third of a cylinder. And if you look at the cone and cylinder formulas, the difference between the volume of a cylinder formula and the volume of a cone formula is that we divide by 3 on the cones, because 1 cone is 1/3 of the cylinder. So let's just pretend that I told you that this cone, the volume of this cone, was 20 cubic inches. So if the volume of the cone is 20 cubic inches, what's the volume of the cylinder? Well, if the volume of the cone is 20, and I know that 3 cones equals the cylinder, then I know that the cylinder must be 60 inches cubed. All right, just to go backwards on this one, let's say that I told you that the volume of the cylinder, all right, so the volume of the cylinder is, let's say it's 120 centimeters cubed. Would you be able to figure out the volume of the cone? Well, let's think about it. If the volume of the cylinder is worth 3 cones, then all I need to do is split 120 into 3 different cones. Then that must mean that the volume of a cone would be 40 centimeters cubed. All right, so that covers Unit 3. As always, if you need to go back and rewatch anything, please do, and make sure if you have any questions, you get those answered as soon as possible.